This last piece to oxidation and reduction is something we'll practice in class, something we'll practice in the lab, and something we'll come back to in a later unit as we apply thermodynamic principles to electrochemistry. But it's good to see it now and start to lay the groundwork. The reason we want to know what is gaining and what is losing electrons, what's going up and down in oxidation number, and what's changing in these ways is so that we can understand how a reaction is happening and in some extreme circumstances get some help for how to balance it. So there is a method called the half reaction method. The nice thing is you very rarely have to do this from scratch, but doing it from scratch really gives you some good skills that help you to understand and apply different reaction types. So we will practice it some together. The first thing is we need to figure out what's oxidized and reduced, and we do that by using our oxidation numbers. We've got our rules right there. Then, instead of thinking of it as one long reaction with an oxidation and a reduction occurring, we take the equation that's the oxidation and we write just that, just the thing that is losing electrons and how many electrons it's losing. We take the reduction half reaction, or the thing that is gaining electrons, and we write just the process for that, gaining electrons. Then we're going to balance that out. But it says to balance everything besides hydrogen and oxygen, because sometimes in the more challenging oxidation reduction or redox reactions, water actually becomes involved. The electrons from water are sometimes donated or they're given to water. Hydrogen ions might become involved in an acidic solution. It's a very different process of balancing. But what we try to do is focus first on the elements that are exchanging or gaining or losing electrons. Then right here, as we think about how many electrons are they gaining or losing. So we look at our oxidation numbers, and then we're really thinking about when it goes from how it started to how it ended, how many electrons needed to be gained or lost during that process. If we can do kind of 1, 2, 3, and 4, we've got most of the main skills here. Assign the numbers and then think about, well, to go from here to there, how many electrons did it gain or lose? And the nice thing is, it's just however much the oxidation number changed. The balancing the rest of it out is super weird compared to any balancing you've ever done, but it's trying to accomplish the same task, to have all of the atoms and elements balanced on both sides to conserve mass, to have the charges balanced on both sides to conserve the charge and number of electrons. So sometimes we have to incorporate or account for some hydrogen ions that are floating around in solution. Or sometimes we have to include some water molecules that may not obviously be a part of the reaction because they're actually providing or receiving some of the electrons that are being exchanged. After we've done that, our goal is to have two half reactions that are written and balanced, and then to put those together to show the total process, to show, okay, this atom lost this many electrons, this atom gained this many, but they have to gain and lose the same amount. So sometimes our two half reactions don't balance on their own, and we have to combine, cancel, or even before that, multiply. But at the end, whether it's redox, whether it's acid-base, whether it's precipitation, our atoms, our charges, our electrons, everything has to be balanced. So this will make more sense to see in class and see in videos when you apply it, but it's something you might want to see a few times, but know that we're just building the skill throughout the year, and we'll come back to it before we have to have that totally mastered.